Hello students, welcome to our YouTube channel Physics for UG. Today in this video we shall discuss, as per NEP syllabus there is a paper that is wave and optics, and in this video we shall discuss about unit 2 of that paper, and it will basically focuses on wave and its equation, also about group velocity and phase velocity, and in this video we shall discuss few short questions and few one-word questions along with few numericals. That will be very useful and that will be very important for your semester examinations. Okay, let's start in the video. So first question, a traveling wave has a rating of 440 Hz at 360 meter per second. How far will two positions be from each other if the corresponding displacement differ in phase by pi radian? That is not radiation, that is pi radian. So what is given in the question? That is f is the frequency, that is 400 Hz, and the velocity v is equal to 360 meter per second. So by using these two formula we can find lambda is the wavelength equal to velocity by frequency. So velocity 360 by 440 equal to 0.81 meter. That is the, because already we have studied many times that velocity equal to frequency into wavelength, velocity equal to frequency into wavelength. So what is asked in the question? How far will two positions be from each other if the corresponding displacement differ in phase by pi radian? That means the phase difference is pi radian, then what will be the path difference? That means by how many distance the two waves differ from each other. Okay, next, so we need to find the path difference because phase difference is given in the question, so you have to find the path difference. So the formula, there is a formula, the phase difference is equal to 2 pi by lambda into path difference, and the path difference symbol is delta x. So what will be delta x? So delta x will be this formula, delta x equal to lambda by 2 point delta pi. Delta pi is the path difference, delta x is the phase difference, lambda is the wavelength, and 2 pi is the factor. Okay, then where the phase difference will be, delta phi equal to pi radian, that is given. So put here pi radian, that is lambda is lambda already obtained, 0.81 meter, 0.81 by 2 pi into pi, that is pi cancel, so 0.81 by 2, that is equal to approximately 0.4 meter. So this is the path difference. So basically what is path difference? Path difference is basically the difference in the path of the two waves. And with the phase difference, so phase means basically the angle, the difference between angle of two waves, that is called phase difference. Okay, now let's move to the next question. Now the question is y equal to x minus vt square a solution of one dimensional wave equation? Given y equal to x minus vt square, is that the solution of wave equation? How to find? Suppose if y is a solution, then that should satisfy the differential equation, that is the most condition. Suppose there is a equation y square plus 2y plus 5 equal to 0. Suppose the solution of this equation is 2. That means 2 must satisfy the value of y. That means if we put value 2 in this equation, then we get the answer 0. So that means the solution must satisfy the differential equation. So now we have to check whether this y equal to x minus vt square is the solution or not. How to check? We know this is the one dimensional wave equation. Del square y by del x square is equal to 1 by v square del square by del t square. Now we have to check y equal this much. Okay, now you have to find left side part, del square by del x square. That means you have to differentiate y with respect to x 2 times, and then you have to find out the value of right side, that is you have to differentiate y with respect to t 2 times, then multiply with 1 by v square. If these two are equal, so definitely that will be solution. That means it satisfies the differential equation. So differentiate partially with respect to x, taking t as constant, because we have to differentiate with respect to t in the right side part. So del y by del x, y is this one, so del y by del x is equal to derivative, that is similar to the formula x to the power n. So that is 2 into x to the power, that is 2 into x, also derivative of del by del x of x minus b, that is just chain rule formula. Chain, that means you have to differentiate up to x value. So 2 into x minus vt, that is as per formula derivative of d by dx of x to the power n is equal to n into x to the power n minus 1. That's this formula we used here. So del by del x of x minus vt, so x minus vt derivative will be, that will be 1, because derivative of x will be 1 and vt is constant, so that will be 0 derivative. So answer will be 2 into x minus vt. That is, suppose take equation 1. Okay, so del y by del x equal to 2 into x minus vt. Again differentiating with respect to x, because you have to differentiate 2 times, because as per the wave equation in the left side part, there is del square y by del x square, so we have to differentiate 2 times. So again differentiating del square y by del x square equal to del by del x of this factor. So what will be the answer? That will be 2 into x minus vt, that is 2 is taken outside because that is constant value which has no role to play in derivative. So del by del x, x minus vt, so x derivative of x will be 1, derivative of x will be 1 and vt will be 0. This will be 1. So answer will be 2 into 1, that is equal to 2. So the left side part is 2. This is the left side part. This is LHS, left hand side value is 2. Now we need to find the right hand side. That is del, we have to find del y by del t, keeping x as constant. So del y del t of x minus vt square, so that is 2 into x minus vt, because that is x to the power n formula. So 2 into x minus vt into del y del t of x minus vt. So derivative of x minus vt will be, x derivative will be 0, because that is done with respect to time t, that will be 0, and a minus vt, so derivative of t will be 1, so remaining part is v, so that will be treated as constant, so that will be minus v. So 2 into x minus vt into minus v, that is del y by del t. Now again differentiate 2 times, double derivative. Now del y by del t is equal to minus 2v into x minus vt, because v is constant, 2 is constant. So again differentiating del by del t, minus 2v into x minus vt, x is constant, so 2v is constant, that is equal to, so the remaining part derivative from t, it will be, extra part will be minus v. So already there was minus 2v, and again from derivative x minus vt there is minus v, because the derivative simple, because derivative of vt is equal to v and a minus vt equal to minus v. So this formula we used here, that is minus 2v already there, minus 2v already there, and then minus v, that is equal to plus 2v square. So the equation, now in the equation that it should be multiplied with 1 by b square. So b square cancel, the remaining part is 2. So 2 is 1 by b, so this much. So this part is RHS part, that is a right hand side part. So LHS is equal to RHS, that is 2 equal to 2. That means the solution y satisfy the equation. That means it should be the solution. It must be the solution of the wave equation. Okay, let's move to the clear. Let's move to the next question. Okay, a transverse harmonic wave is given by y equal to 3 sine 36t plus 0.018 x plus pi by 4, where y and x are in centimeter, t in second, that is in CGS system. The positive direction of x is from left to right, that is we assumed in the question that from x axis this is positive and this axis is negative. First question, is this a progressive or stationary wave? If it is progressive, then what are the speed and direction of its propagation? You have to find this one. What is the initial phase of at the origin? What is the starting phase? Phase means what is the angle in terms of pi, you have to find what is the initial phase. What is the amplitude and frequency of the wave, and what is the least distance between two successive crests? That means that is the wavelength lambda. That means in the question you have to find amplitude, you have to find frequency, you have to find amplitude, and you have to find initial phase. That is, suppose we denoted phi naught, initial phase, and whether this is progressive wave or stationary wave. But first we have to find out the speed and direction of propagation. Okay, let analyze the question. Y equal to 3 sine 36t plus 0.018x plus pi by 4. So that is equal to y into 3 sine 0.018 taken common, because we taken common, there is no need to take common. You can solve it by without taking the common, because this is our standard form of our solution of the wave equation. That is y equal to a sine omega t plus kx plus phi. What is omega t? So in this question, remove that part. There is no need to write this one. What is a? A is the amplitude. So amplitude, compare this one. Amplitude is 3. So we get a equal to 3. What is omega t? Omega t. There is omega t. Omega equal to 36. 36t. So omega equal to 36. What is omega? Omega the angular frequency. So angular frequency means 2 pi f equal to 36. That implies f is equal to 36 by 2 pi. That means 18 by pi. Okay, that is frequency. So what is next part? What is frequency? Then that is kx. That is kx. So here that is 0.018x. Compare this one. So k will be 0.018. So k value is 2 pi by lambda, reciprocal of wavelength 2 pi by lambda equal to 0.018, and then lambda will be 2 pi divided by 0.018. So lambda we found, frequency we found, then velocity equal to frequency into wavelength. Okay, then what is initial phase and this phase phi? This is the phase. Now let's check the solution. Okay, but this is the way. Amplitude a equal to, already a equal to 3 centimeter. K, that is k equal to 2 pi by lambda equal to this much, lambda equal to 2 pi by 0.08. Bus, this is one clear. Frequency equal to also we write here, that is lambda is velocity is, you can find velocity, and velocity equal to frequency to wavelength. But by using this formula also you can calculate frequency. And what is pi? Pi equal to pi by 4. Pi by 4 already I have already told you that pi equal to pi by 4. Look at here, this is the initial phase. Pi the pi by 4, pi the pi by 4. By looking this equation you can easily find the answers. Okay, there is no need to worry about the question. Okay, next wavelength. Distance between two consecutive crests is equal to wavelength. So lambda equal to b by f. Okay, now another part. What is there is a first question. It is a progressive wave traveling along negative x-axis from right to left, because we shall discuss about the formula. If in the equation this is omega t, this equation omega t plus kx, that means it moves in the negative x direction. If this equation is omega t minus kx, then it moves in positive x direction. But you have to remember, if omega t minus kx, then negative x direction. If omega t plus kx, then negative x direction. If omega t minus k, then positive x direction. Okay, so this wave travels in the negative x direction because omega t plus kx is there. Okay, let's move to the next question. A wave packet of mean wavelength 3.6 into 10 minus 5 centimeter is traveling with phase velocity of 1.8 into 10 to the power 10 centimeter per second in a dispersive medium. From the dispersion of medium, dv by d lambda is computed to be 3.8 10 to the power 13 centimeter per second. Calculate the group velocity in dispersive medium. Okay, what is given in the question? First of all, look at here. A wave packet of mean wavelength 3.6 minus 5 centimeter, that is the wavelength. So lambda is equal to 3.6 into 10 minus 5 centimeter. That is first part is given. Okay, with phase velocity, that is v, this is the phase velocity, v equal to 1.8 into 10 centimeter per second, that is phase velocity. Clear? For dispersive medium, dv by d lambda is given, dv by d lambda is given this much. There is a simple formula, group velocity Vg equal to v minus lambda dv by d lambda, and Vg is the group velocity, v is the phase velocity, and lambda is the wavelength, dv by d lambda is the rate of change of velocity with respect to lambda. So put all these values clearly, put v here, put lambda here, this one is lambda, and put d value, everything is given in the question. So easily you can calculate the answers and easily you can find the answer. Okay, there is no need to worry about, but simply calculate the values, put the values and calculate them. So by using simple mathematics, so Vg is equal to, so Vg is equal to 1.66 10 to the power 10 centimeter per second. Okay, thank you. Let's look to the next question. Okay, that's quite an interesting question. In a ripple tank, 10 full ripples per second are produced. The distance between a trough and a crest is 15 centimeter. Calculate the frequency, the wavelength and the velocity of the ripples. Okay, first look at the question. In a ripple tank, 10 full ripples per second. So 10 full ripples means, that means there are 10 ripples or 10 waves per second. So per second means the frequency is the number of repetitions per second, that is frequency. So definitely frequency is the number of ripples produced per second, that is frequency equal to 10 hertz. Frequency is 10 hertz. And another thing what is given, the distance between a trough and a crest is 15 centimeter. So in case of a wave, this is the crest and this is the crest, and this distance is wavelength lambda. Suppose this is a crest and this is trough, so this wavelength will be lambda by 2. So distance between a crest and a trough is lambda by 2, whereas distance between two consecutive crests is lambda. So what is given in the question, distance between a crest and a trough, that is 15 centimeter. So lambda by 2 equal to 50 centimeter. So lambda equal to 30 centimeter. So velocity v is equal to frequency into wavelength. That is most familiar equation in wave chapter, that is velocity equal to f into lambda. So f is 10 and lambda is 30, that will be 300 centimeter per second. Look at the units, velocity, that is 300 centimeter per second or 3 meter per second. Clear? Now look at the next question. Okay, this is also very important question. This question is very important for exam point of view. Okay, the wave velocity v of a transverse wave in a crystal of atomic separation A is given by v equal to a sin k by 2 by k by 2, where a is constant, k is wave number. What is the group velocity? That means wave velocity means that is the phase velocity is given, that is the phase velocity. So you have to find group velocity. So what is wave velocity? V equal, that is given, and this part and this line is the given part. Okay, we know there is two formula. Remember, the wave velocity v is equal to omega by k, and the group velocity vg is equal to d omega by dk. Now we use these two formula to solve this question. Group velocity v is equal to d omega by dk. So v equal to omega by, that is simple formula. So what is omega? Omega equal to k into v. From this part, omega equal to k into v, that is k into, what is v? V is a into sin k by 2 by k, that is given in the question. Okay, that is equal to 2a by 2 sin k by 2, because this k is cancelled. So 2 move to offside, that is 2 into capital A by small a. 2 into capital A by small a sin k by 2. Now what we need to find? Group velocity Vg. So Vg equal to d omega by dk. So d by dk of omega. What is omega? This is omega. So omega value put here. Okay, this is omega. So by taking derivative d by dk, so in this part 2a by a is taken constant, so 2a by t is taken outside of derivative d by dk of sin k by 2. Derivative of sin equal to cos k by 2. Sin is cos k by 2 and that is cos k by 2. Also derivative of k by 2, that is equal to a by 2, because that with respect to k, so that will be a by 2. So 2a by 2 already there present constant part, a by 2 from derivative of k by 2 and cos k by 2. So the answer will be a cancel, 2 cancel, the remaining part is a cos k by 2. Vg equal to cos a cos k by 2. There are many questions by using this formula or by using another formula. Already we have discussed in the previous question. Vg is equal to v minus lambda dv by d lambda. This is also known as the relation between group velocity and phase velocity or wave velocity. Okay, if this v is given, then you have to find Vg. If Vg is given or anything lambda dv lambda is given, then you have to find Vg. So this formula is very important. In order to solve such type of question, you have to use this formula. Also you have to use v equal to omega by k formula, also Vg equal to d omega by dk formula. Okay, now I think it is clear. Now let's move to the next question. Okay, two sinusoidal waves are superimposed. Y1 equal to 0.04 cos 15t minus 8x and y2 equal to 0.04 cos 90 minus 6x. So y1 and y2 are the displacement of the two equations and y1 and y2 are in meters. In second, calculate the group velocity. What is the formula for group velocity? Group velocity is d omega by dk. Group velocity Vg is equal to d omega by dk. That means change in omega by change in k. So what is omega here? In this equation, what is omega and what is k? Remember, there is the equation y equal to a sin or a cos. Both will be right. A cos omega t minus kx. So from this equation, omega t. So in first equation, omega 1 is equal to 15 and in second equation omega 2 equal to 9. Remember omega t, so that's 90. So omega 2, so in the second part, kx, that is k1 equal to 8 and k2 equal to 6. Look at this equation. Cos 90 minus kx means omega t minus kx. This is cos omega t minus kx. So k will be this much. So what will be the group velocity? V is equal to d omega by dk. D omega means d omega by dk, that is phase velocity, equal to omega 2 minus omega 1 by k2 minus k1. Omega 2 is 15 minus 9 divided by k2 minus k1, that is equal to 6. Or easily you can find the difference, but you have to find the difference. Okay, clear. Take the mod. If you take this one, then take the mod 6 minus 8. So that is equal to 15 minus 9, then 8 minus 6. That will be 8 minus 6, because this one 15 minus 9 by 8 minus 6, that will be 6 by 2, that is equal to 3. All are in a SI system, so that will be 3 meter per second. That is the formula for group velocity. So already it has been solved in this page. Okay, now clear. Let's move to the next question. Okay, this is quite bit hectic type question, but very interesting. Okay, find a and b. You have to find a and b. A and b are constants, so that a sin omega t plus b cos omega t equal to 2 sin omega t plus pi by 6 in SI units. Okay, you have to find a and b. Given that a sin omega t and b cos omega t equal to 2 sin omega t plus pi by c, that is given. Then let x equal to a sin omega t plus b cos omega t. Then we can write this equation as in each part we divided a square plus b square root over in each part and multiplied this same factor. So after multiplying, then both will be cancelled, so remaining part will be the first line, this line will be, and dividing in the second part also, dividing a square plus b square root over and multiplying also this one. Okay, same thing. Okay, now put a by a square plus b square root over equal to cos phi, means this bracket part is equal to cos phi, and this bracket part and this part is taken as sin phi. So for the equation, x equal to a square b square root over cos phi sin omega t plus sin phi cos omega. That means this equation will be cos a into sin b plus sin a into cos b. That is the equation of sin a plus b, because sin a plus b means sin a into cos b plus cos a into sin b. Sin a plus b, that is a square plus b square root over sin omega t plus pi by 6. Okay, so from this, now compare this equation with the first given equation in the question. Compare this one. So we get 2 equal to a square plus b square root over, and what is phi equal to pi by 6, that is given in the question, omega t plus pi equal to pi by 6. So what is cos phi equal to a by a square plus b square root over. Okay, so now put cos phi equal to pi by 6, so cos pi by 6 equal to a by 2, and because a square plus b square root over is 2, so cos pi, that is a by 2, and what is cos pi by 6? Cos pi by 6 means 30 degree. So cos 30 equal to root 3 by 2. Root 3 by 2 equal to a by 2, and we use solving this equation root 2 to cancel, so a equal to plus root 3. So a equal to root 3. Similarly, we use sin phi equal to b by a square plus b square root over a square plus root over is 2. So b by 2 equal to sin phi. What is phi? Phi is equal to pi by 6. Pi by 6 means 30 degree. So sin 30 equal to 1 by 2. So 1 by 2 equal to b by 2. Because a square plus b square root over is 2. B by 2 to cancel. So b equal to 1. So we have to find this. In the question it has been asked that find the value of a and b. So a equal to root 3 and b equal to 1. Clear? I hope you understand this question. This is quite well lengthy, but that is similar to tricky type question. Okay, let's move to the next question. There are no more problems, so now we shall discuss some theoretical questions. Okay, listen carefully. Listen very carefully, and you have to remember these lines. They are very fundamental things, they are very basic things, and easily you can remember already. First question: name the different forms of energy which can be transmitted from one place to another with the help of wave motion. Okay, what are the different forms of energy that can be transmitted from one place to other with the help of wave motion? So various forms of energy, for instance heat energy, light energy, sound energy, electromagnetic energy, radiation, can be transmitted from one place to another place with the help of wave motion. So this is basically the transformation transmitted. This heat transmitted from one place to another place, light transmitted, and sound transmitted, radiation transmitted. So these are the different things that can be transmitted from one place to another place. So next is, what is a wave? Define it. Remember, I have already taught in my video, a wave is a disturbance which travels through the medium and propagates energy and momentum from one place to another without the transport of matter. So wave is basically disturbance. Suppose there is a still water, there is a rest water on a bucket. If we put a stone on it, then it will form a wave like structure. So that means we disturb that water surface. That's why a wave is basically a disturbance which travels through the medium and propagates energy and momentum from one phase to another phase. Okay, so in wave there will be another question. So in wave, what part propagates, that is energy and momentum are propagates without transportation of matter. That is, matter is not transporting, energy and momentum are transported. Okay, next question. What are conditions that must be satisfied by the medium for transport of energy by wave motion? So the medium should be elasticity, inertia, and minimum friction should be there. This is nothing, and the minimum friction should be there. Okay, inertia should be there, elasticity should be there, and minimum friction should be there. So these are the three conditions that must be satisfied by the medium for transport of energy by wave motion. Okay, next is, what is the most fundamental property of a wave and why? Frequency is the most fundamental property of a wave. It is independent of the nature of medium through which the wave is passing, because it depends upon the source. So frequency is source dependent. That means frequency depends upon the source from which wave starts. The propagation wave starts from the source. That means from the source, frequency depends upon the source, and the frequency does not depend upon the path, whether light or whether any wave travel inside. Suppose that wave travel in air, then travel in water, then travel in glass. In every case, velocity changes, wavelength changes, but frequency no change. Frequency no change, because frequency does not depend upon the medium, does not depend upon the path, because frequency is a source dependent factor. It depends upon the source. If we change the source, the frequency will change definitely. Okay, what does a traveling wave carry along? A traveling wave carry energy. Next, name different types of wave motion. Types of wave motion are, one is longitudinal and there is transverse wave. Okay, next question, define longitudinal wave motion. Longitudinal wave motion means along the length. That means it is a wave motion in which particles of the medium vibrate to and fro about their mean positions along the direction of propagation of wave. This is the important phrase. The particles vibrate along the direction of propagation of the wave. That is the longitudinal wave motion. Examples are sound wave and spring wave. Examples are sound wave, longitudinal wave motion, sound wave, and spring wave. So in case of longitudinal wave motion, there are compressions and rarefactions, but in case of transverse wave, there are crests and troughs. Clear? Now define transverse motion. What is transverse motion? In this type of wave motion, particles of the medium vibrate perpendicular to the direction of propagation. This line is very important, and about the mean positions. So what type of wave is this? Whenever this is the direction of wave propagation, so the particles move up and then down, up and down, up and down. So this vibration of particles is perpendicular to the direction of propagation. So here this is the formation of crest and formation of trough. This is crest, this is trough. So this is the situation of a transverse wave motion. So are the examples, water wave are the examples of transverse wave motion, and then light wave or electromagnetic wave transverse, light wave transverse, and then string wave. String means a small thread type material. String wave, water, light, string are the definition or the examples of transverse wave motion. Okay, next question, which type of waves can travel with velocity of light? Transverse waves can travel with velocity of light, because transverse wave example is light wave. So light wave or electromagnetic wave can only travel with speed of light, that is 308 meter per second. That is very clear. Longitudinal wave is basically sound wave. The speed of sound is approximately 330 meter per second or 340 meter per second. Already we have discussed in another video. 3340 meter per second. So this is the velocity of sound in air, and this is the velocity of light in air, that is 380 meter per second or 3 lakh kilometer per second. Okay, define wavelength of a transverse wave. So wavelength is basically, in the figure I have already told, in the figure, if this is the wave, then this is crest, this is crest, the distance between two consecutive crest is lambda. Two consecutive crest is lambda, and distance between two consecutive trough is also lambda. So the distance between two consecutive crest or troughs of a transverse wave is called its wavelength. Their symbol is lambda. Okay. Next, define wavelength of a longitudinal wave. Similar to the distance between two consecutive compressions or rarefactions is called wavelength of longitudinal wave. That means this is the compression part and this is the rarefaction part. This is the compression part and this is the rarefaction part. So rarefaction, that is R, means particles are rarely present, and a compression means that the particle density is high, density of particles is high, pressure is high, and the particles are more compact. And in case of rarefaction region, the particles are loose, that means they are apart from each other, and there is low density of materials. That's why they have compression rarefaction in longitudinal waves. Okay, clear? Next, what is the change in density of medium during transverse wave motion? There is no change in density of the medium during transverse wave motion. Density of the medium, no change. That's actually medium. Medium means medium, no change of the medium. Okay, medium means suppose light, suppose a wave travels inside a water medium or glass medium or in air medium. Is there any change in the medium or water, so glass or air? No. Density of the medium never changes. Density of the medium always remains constant. Density of water is 1000 kg per meter cube. Density of air is 1 kg per meter cube. So in that situation, so in during transverse wave motion, there is no change in density of the medium. Okay. Now, write the equation of a plane progressive wave moving along positive direction of x-axis. If the wave travel along positive direction of x-axis, so the equation will be y equal to a sine omega t minus x. Remember, this is the negative sign. So negative sign means positive x direction. This positive sign means negative x direction. But remember this one clearly. The equation of a plane progressive wave moving along the positive x direction is given by y equal to a sine omega t minus kx. Omega t minus kx means plus x-axis, omega t plus kx means minus x-axis, just opposite. Okay, clear? Next question. Write the equation of a plane progressive wave moving along negative direction of x-axis. Same thing I have already repeated. Y equal to a sine omega t plus kx. So plus kx means negative x-axis, negative x direction. So that is plus, this is the change, plus kx. Okay. Write the equation of a plane progressive wave motion along positive direction of x-axis with initial phase phi naught. Initial phase phi naught. So the equation is y equal to a sine omega t minus kx plus phi naught. This phi naught is the initial phase. If the initial phase is 0, so the equation will be omega t minus kx, similar to the previous two questions. So it travels the positive x direction, so that will be omega t minus kx. So minus kx means plus x direction. Already I am repeating 3 to 4 times already. I have repeated these points. Okay. What type of waves are produced in air? In air, longitudinal waves are produced in air. Okay, but transverse waves can be produced in vacuum also. Clear? What is the nature of sound wave? Sound waves travel in the form of longitudinal waves in gases and liquids. However, in solids it can travel both in the form of longitudinal and transverse waves. So sound wave is basically the longitudinal wave in case of gas and liquids. Okay. Can transverse waves be produced in air? For air, the modulus of rigidity is 0. Rigidity modulus, that is rigidity modulus, that is a part of elasticity. In other words, air or gases don't possesses the property of cohesion. Cohesion means sticking together, cohesive force. Therefore, transverse waves cannot be produced in air. Okay. Why is the wave propagating through a string called transverse? It is called transverse because the particles of the string vibrate perpendicular to the direction of propagation of the wave in the string. If the waves vibrate if the particles vibrate perpendicular to the direction of propagation, then that wave is called transverse wave. If the wave travels in the direction of propagation, then that wave is called longitudinal wave. Okay. Now let's view one other questions. What is the type of water wave? Transverse wave. Clear? Transverse water wave means transverse wave. Transverse wave also light wave, also string wave. Transverse wave. Okay. Whether a medium is required for wave motion? Yes. Wave motion medium is required because a medium is there mostly. Which type of wave traveling out from a point source? Sound or light waves? From a point source. Whether the traveling waves can three-dimensional? Yes, that means three-dimensional. Okay, give an example of longitudinal waves. Sound waves. Can longitudinal waves be polarized? No, only transverse wave can be polarized because the property of polarization, that property of polarization in optics can be observed only by light, not by sound, and not by sound. Sound cannot be observed, and sound cannot show the property of polarization. Sound can be interference and diffraction, but polarization is the characteristics of only transverse waves. Remember, this is the very important point. And this one is important. What type of wave produces polarization? That is only transverse waves. Only transverse wave produce polarization. Can transverse waves be polarized? Yes, they can polarized. Yes. There is no not answer. Can transverse polarized? Yes, transverse wave can be polarized because light waves can be polarized. Can transverse waves travel through vacuum? Yes, in vacuum. Suppose transverse wave is light wave. Transverse wave means light wave. Suppose this is sun and this is earth. When the light comes from sun to earth, and this part is vacuum. This part is vacuum up to few 100 kilometers. There is air, but above that area, above that part, there is vacuum. There is nothing. Even air is not present. So light can travel also inside vacuum or inside air, inside water as well as inside glass medium. So light can travel through gaseous medium, to solid medium, to liquid medium, but longitudinal wave cannot travel through vacuum because longitudinal is sound wave, the sound is longitudinal, and sound cannot propagate in vacuum. In vacuum, if we speak something, we cannot listen to that. So there is we cannot listen to the words on a moon surface or in another planet where there is no atmosphere, there is no air. So when there is no air, you have already you might have performed the experiment in your school time that in a evacuated vacuum chamber, suppose there is no air in the chamber, then if you speak something, then the other person cannot listen to that. Okay, so I am clarifying once again that is very important. You have to remember transverse wave can travel through vacuum, also can travel through in a medium, but longitudinal wave cannot travel through vacuum. The longitudinal waves that must need a medium to travel. Okay, what is the name by which the wave velocity is called? Wave velocity also called as phase velocity. Okay, what is the physical quantity which is transmitted through the medium from part of medium to other in the direction of wave? That is, energy is transmitted. Okay, clear? Thank you. If you like this video, then subscribe the channel, like the channel, and you can get update for more videos. Thank you.